Good morning, good afternoon, good evening, wherever you are. My name is Bill O'Dell, and I'm the Chief Marketing Officer at Aerospike, and I'm here to moderate the next breakout session. In this session, you're going to hear from Quantcast. They're a real-time bidding and management platform. They're going to talk about their journey in building their application on top of the Aerospike database, and they're going to share with you the tips and the things that they've learned along that journey, which we hope will be helpful for you. So with us today from Quantcast, we have Kristi, Tsukida, and Paul Revere, both engineers at Quantcast, hands-on with Aerospike, and they're going to share with you what they've learned. I want to point out one housekeeping thing, though. If you have any questions throughout this presentation, just look to the left of your console for the question mark icon and click on that and go ahead and submit your questions at any time along the way. I will take a look at those as Paul and Kristi share their remarks, and at the end I'll come back on and present your questions to them. So with that, I'll turn it over to our good friends at Quantcast to share with you their remarks. Take it away.
All right, so we're going to start off with covering a little bit about Quantcast. Like a number of the other attendees of this conference, we're a company that operates at the scale of the web, and we need to run around the clock. Also, like some of the other attendees of this conference, we're an online advertising platform. The goal for Quantcast is for us to simplify advertising on the open internet for our customers. In addition to our online advertising business, we run an online measurement platform as well that provides publishers information about their visitors. And then we also run a consent management platform. It is a consent tool for measurements, and it is fairly widely adopted. You'll see here on the screen, this is called our choice dialog. This shows up on a lot of web pages in the EU. You might be quite familiar with it if you're in Europe. So to cover real-time bidding quickly, so Quantcast participates in real-time bidding. This is the way that internet ads can be targeted to users in real time. If you consider other media sources, such as TV, newspaper, radio, an advertisement really gets blasted out to thousands or millions of people at any given time. But it doesn't let you really target the sort of people that you want to actually reach. It doesn't let you reach specific audiences. But on the internet, we can actually tailor ads for individual users while a page load is happening. So that's really what's happening here is, as web pages are loading, our algorithms are trying to pick the most relevant ads to show users at that specific point in time. So with this great targeting ability that we have some great engineering problems along it. We operate at internet scale. That means we have a huge request volume. We have about 4 million requests per second on our bidding stack. We have enormous data volumes. We are storing the data for billions of users. We're storing data for billions of browsers and cookies. And we have terabytes of feature store data that's available on our edge at any given point in time. And then we have to do updates to it in response to user behavior in real time. We also have very tight latency requirements on our bidding stack, since all of this is happening as a web page loads. Our P99 latency of our bidding stack is about 40 milliseconds. So to give a picture kind of the systems involved here, really, we're looking at the web page load time, which typically is under 2 seconds. And then within that, there's the time that it takes for an individual ad to load. And then, as that ad is loading, an auction goes off inside an ad exchange. Quantcast gets a request, and then, as a part of serving that request, we have to do a data lookup, and that data lookup is being done to our feature store, and that lookup has to have a median latency of around a millisecond. So that's really kind of the world that we're operating in. This extremely fast lookup time. That we have to provide data for these requests. I'll keep giving the presentation so that while Kristi gets a chance to fix her mic. So this presentation is really going to kind of be a story of our migration. And every good story, it has a villain. In this case, it was our legacy custom-built key value store. It was called Keebler. And we shouldn't really consider this to be an all-evil villain. We're talking about a database that supported our company for years. But it had a lot of confusing behavior. It was hard to update, and it was hard to really like kind of iterate on in order to launch new products. But still, this was a custom-built database that was able to serve the use case for a very long time. It was running just as well, like with our bidding stack running for it. All right, so it's worth covering the team that we had for this. It's not just me and Kristi. There's a whole team of us that worked on this. We're an interesting bunch, but we've been able to get the job done. So I'd just like to start off by saying thank you to everyone on the team for this.
Is this working now?
Oh, sounds like Kristi's back.
Okay, I'm back.
All right, why don't you take over?
Okay, where are we? Sorry. Right. Yeah, this is our team. It took a lot of people, a lot of work. We've been working on this for the last year and a half or so. We sort of skew high on cartoon characters. We've also got a couple of PhDs and a couple of grad school dropouts. It's been a great journey, and it's been a lot of fun, a lot of heartache, but it's been great to get this going. So a little spoiler alert: in the end, we do win. We kill the dragon. We shut off Keebler. This is a nice little graph of all the Keebler machines being killed off, and they quickly tank to 0 and is gone and dead. A funny little thing that we do, we pull up all these balloons, we write the name Keebler on them, and then at the company meeting where we announced this, that we finished this and we've destroyed Keebler, we pop all these balloons, and it was really a lot of fun. I really recommend popping balloons when you kill systems, or just when you're excited about something. We've been meaning to plan an in-person party, but since this just happened in March, and then we're not great at planning ahead, and then this whole COVID thing hit. Now we're all stuck at home, so party is postponed. We'll be throwing a giant party once we get back into the office. But yeah, we did it. It was hard work. We're really excited about it. So here's a little timeline on how things happened, and there's sort of a lot involved here, but something notable to point out is that we almost immediately started developing new products. Like, we actually had a deadline to get Aerospike clusters into production so that we could start developing new products. It kind of took longer than we thought to get things up and running in production. We had an original POC early on, and then it took us a long time to do a bunch of data validation and performance tuning. I'll be getting to some more details about the things that happened, but really, like, getting the first use case into production was pretty difficult, and subsequent use cases weren't as difficult. But it did end up being trickier than we thought it was going to be. So the first use case that we migrated, we called a feature store because it stores features on cookies or browsers. So we started with the proof of concept. We ran a synthetic benchmark. We loaded it up with data. We didn't do data validation. We were most concerned with the performance and specifically the performance of the server, which we believed our synthetic benchmark would show the performance of. We had initially thought that our proof of concept would involve trying to run this in our production and just like making the queries but not using the data. But because when we were running this proof of concept, it was during the holiday period, and for advertising, the holiday period is where we do a whole lot of business because that's when everybody's buying things. So that's when everybody's trying to show ads to make people buy things. So we have these extended code freezes during the holiday season, and we were worried that we wouldn't be able to effectively iterate and deploy things during the holiday season if we were trying to benchmark things on our production systems while code freezes were going on. So we actually changed our minds on that and went with a synthetic benchmark. And then when it came to productionization, we started running it in production. We stood up an Aerospike cluster and we're making parallel queries both to the old legacy data store and to the new data store and comparing those results, validating the data that we were getting back and evaluating the performance that we were seeing. And what it turned out that the server performance was actually pretty accurately covered by the benchmark, that our servers weren't having problems. So we ended up having a lot of problems with the client latency performance in our production environments. And our production environments actually, we try to optimize them to run very efficiently. So they take advantage of all the CPU that's available. And so they normally typically run like greater than 90% CPU utilization. So it was a bit of a struggle to figure out how to get them to run well enough with low latency so that we could actually be using this reliably in production. I guess another small note about our legacy system was that our legacy system had been running based on UDP messages, whereas Aerospike runs on TCP messages. So there was sort of a fundamental difference on how they were handling the messages. Like we would prefer that Aerospike was able to handle UDP, but we thought we'd be able to get it to work well enough for our use case. So into a couple of the Aerospike hacks that we use to get this up and running. That we use an AWS-backed ELB DNS entry for the Aerospike mesh seed address. So if you don't know a whole lot about Aerospike, the mesh seed address is the way that a host identifies other hosts that are in the same cluster, and that's how it joins the cluster. Obviously, the host needs to know which other host there. So it needs to be pointed at least one host to join the cluster. So it's convenient for us to tell us to have an ELB, an elastic load balancer, that has all the hosts connected into it. And then when you need to connect to the cluster, you just connect to the ELB and say, okay, like who's in the cluster? Like otherwise we'd have to maintain a whole separate list of either DNS entries or IP addresses, which seemed like a lot of maintenance. It seemed much easier just to let AWS handle this ELB because it's really easy to hook up EC2 instances from an auto-scaling group into a load balancer. This is technically not recommended by Aerospike support. I think earlier versions of Aerospike wouldn't have worked at all. There might be some small issues. It's a little bit finicky when you're spinning up a new cluster. Sometimes they have trouble connecting to each other. Maybe it's weird DNS things. You never quite know with DNS, you know. At least in our office, we like used to have this funny little DNS haiku. And anytime there's like weird problems that might be network problems or might be DNS problems, it's always like, oh, it's not DNS. It's never DNS. And then you discover it's DNS. In this case, DNS is not our problems. Or I don't know, maybe it is part of the problems when you're spinning up clusters. But this has worked well for us for auto-scaling groups. It's also worked for telling the Aerospike client of how to connect to the cluster. The client also needs at least one host to connect to, and then that host tells it all the other hosts in the cluster. So I don't know. It's a bit of a hack. Maybe it's not officially recommended, but we use it. So there has been like one little bug while we were using this Nest Suite address that we ran into, like in between running the POC and then trying to productionize it. I decided it would be good to upgrade our Aerospike versions. And when I did that, we noticed that the clusters were no longer able to connect to each other. And I've dug into the logs. I was like, well, maybe there's some weird DNS thing happening, or maybe there's something else happening. And I noticed the logs were printing out the load balancer address that we were using, but it was like cut off at some point. And then I emailed support. It was like, hey, we're having problems. It looks like between these two Aerospike versions, and this is what I'm seeing in the logs. And they respond back almost immediately, like, okay, like we'll look into what's going on here. And within an hour, I have a bug report on their side, like, oh yes, we've confirmed that this is an issue. We'll be looking into it, and 5 days later, they've released a fix for it. There's a new server version. So this was just an example of the amazing support that we've been getting from Aerospike. We've been in contact with them a lot. We try to get like their advice when we're like starting up a new use case and trying to figure out what is the best way to use Aerospike. And when we're doing, we did like a migration of instance types, and they recommended some ways for us to do that effectively. So just thank you to Aerospike support. It's been amazing. It's been an amazing experience. Keep up the good work. Okay. A couple of other space-saving tricks that we've been using. We store our indices in memory for performance reasons, because it's faster to access your data when you have the indices already loaded into memory. This means that our memory usage scales with the number of records that we have. So we've tried to have a single record with multiple pieces of data in it, different from like in a relational database where you would have multiple tables, which with each different like types of data. So sort of having this like denormalized view of the data where we only have to access a single record means that our lookup times are faster, because we only have to do one lookup instead of looking up things in multiple sets. And it means our memory space usage is low. We've been able to increase our high water memory mark from the default 60% because we run a medium-ish size cluster. We have like 18 nodes in our cluster. So we've been able to bump this up to like 80% because we think we have enough headroom for it. We run at a replication factor of 2. So we want to know that if one node goes down, that the other nodes can cover for that node. When allocating new namespaces, you want to look at the memory that you've allocated in your configuration. That you don't want to be looking at what memory you're utilizing. Like, it's easy to go onto your host and be like, oh, this host has like 20 gigabytes free. We can totally like use a 20 gigabyte memory thing. Like, and actually, no, you can't. You can't just keep allocating 20 gigabyte things until you're like over allocated. Like, you can't allocate shouldn't allocate namespaces for more memory than your machine has. So like we've run into a little bit of this. Should also know that Aerospike does things in SI notation, gigabytes, and base 2 numbers, not the base 10 numbers. So this can cause you to be off by a small fraction. Sometimes that small fraction matters. Sometimes you catch the issue before it happens. We actually managed to catch this before we disastrously ran out of memory, but something to be aware of. For disk space, we've been able to sort of squeeze more disk space usage out. There was a while when we were back on C5D machines where we were sort of running tight on disk space, and we had to get a little clever on giving ourselves a little more headroom on disk space. So we've increased our disk high watermark and our defrag low watermark percentage. So the defrag low watermark percentage is when as Aerospike like starts writing a full block, and then as the cluster goes on, some of those blocks like get marked as like not being used. So when that block hits that low watermark percentage, it gets scheduled for a defrag and gets combined with a bunch of other blocks to be rewritten as a full block. So we've raised this up so that more defragmentation will happen, so that we're storing data at a higher density. And it causes more writes, it causes more wear on the hardware. We're in AWS, so we don't own the hardware, so we're sort of less concerned about that. But that's been like a useful little hack to like squeeze out a little bit more memory space. For our data, we've also tried to lay this out efficiently. We use single characters for the bin names. We've used lists in places instead of maps because lists take up a few less bytes than maps, and when you have billions and billions of records, every little byte counts. We've set a new epoch on our timestamps so that our timestamps have smaller integers, and we've actually saved like a good, hundreds of gigabytes by doing this. And like, I know it sounds kind of silly, like, why do we need a new epoch? How many epochs do we need? And sometimes it's the useful data optimization to have a new epoch. There are engineering reasons why you do these things that sometimes look kind of weird when you're like going through code. A couple other AWS issues that we've encountered. We've initially tried to run in placement groups, ideally in a placement group with our whole RTB stack, but our stack is just too big to fit, and it's too hard to like get AWS to put all of our hardware like co-located next to each other for low latency. We've had a bunch of capacity issues whenever we're trying to spin up a new large cluster. Seems like we always run into something. Like when we were trying to stand up our first production cluster in Singapore, we couldn't get enough C5D instances to run a full Aerospike cluster there. And we went back to like our AWS representatives, and they were trying to help us out. They were like, hey, if you move your stuff into this other availability zone, there's more free instances there. And there was a good few weeks where we were trying to figure out like, okay, can we take our whole RTB stack and move it all into this other region? We had a plan. Okay, we'll spin it all up in a new availability zone, and then everything will just run there. And that was really hard to do. We tried to do it, but we couldn't get it running. It's tricky to start things up. Eventually, we got really lucky, and we just tried again to get C5D machines in the same availability zone that we had been running in, and we eventually got them. So we kind of lucked out, but just being in the cloud doesn't absolve you from having capacity issues. This is a lesson we've learned over and over again with AWS. There was some reservation juggling that we had to do. We reserve our instances, and we've had to like reserve them, and it's been difficult to get all of our reservations coordinated with all the other teams. Initially, we thought that we would be converting the reservations from our old legacy system into new Aerospike instances, but because we were running in parallel for so long, we actually ended up making new reservations for our new machines, and had to sort of like sort out what all of the rest of the reservations are going to be. We eventually, like as a company sort of policy, like set one person, like, okay, if you have to make a reservation, talk to that person, and they have like a good global picture on what our reservation status is. Because a few months ago, AWS just put out savings plans, which are infinitely easier than reservations, where it's just CPUs that aren't tied to zones or instance types. So we're excited when all of our reservations will expire and we'll just be in savings plans. But until then, we have to do some reservation juggling. And we've discovered very recently that AWS can sometimes put many of our instances on the same physical machine, and that physical machine can have issues and die, meaning that we lose multiple nodes at the same time. So we don't have a way around this, but it seems it's pretty rare. It happened to us for the first time just like a week ago. But it can happen, and there's sort of like not much you can do to prevent this from happening. So yes, disasters can happen, and you're going to want to be prepared for disaster. We have destroyed our clusters in a few different ways. We had a time where we accidentally terminated half of a cluster. We had a time where we deleted all the data in our cluster, and in these times, it's been great to have a tested disaster recovery plan. Like we ran a full, when we were putting this into production, we ran a full test recovery. So we know approximately how long it takes. We know whether there's steps in it. In testing this, we actually realized that we wanted to be loading our data in a different order. Like we had been loading data from oldest to newest because that's just the way it shows up. But we realized we wanted to load it from newest to oldest because the newest data is the most valuable data. So we had to make that change. And we discovered that when we were testing our disaster recovery. But I think the biggest lesson that we've learned is that the client performance is just as important as the server performance. So we weren't very concerned with the client performance when we were doing our POC, and our synthetic benchmarks were mostly testing, like, can the server handle this load? Can we be writing and reading all of this data from the server? But the real struggle for us has been getting the client to be performant. And so early on when we were debugging things, we were trying to figure things out, and we added in some monitoring for the Aerospike client. And I just wanted to call out this get cluster stats that you can call on the Aerospike client that can get you stats on the number of connections that are used and in the pool. And we do asynchronous lookups, so we have an event loop. So there's also event loop stats, like the number of commands in the queue and the number of commands that are in process that have been useful in our debugging. One of the client problems is that we get connection spikes because we run it in a low latency situation. So we set our timeouts to be pretty low. But having timeouts that are really low can cause a timeout, which can cause a socket to close, which then the client needs to make a new connection. And when you're doing this at millions of times per second, you're then making millions of connections per second. And it's really easy to hit the limit of connections that your server can handle. So we've tried tuning some of these parameters that you can set on the Aerospike client, including the timeout delay, the socket timeout, and the total timeout. We've also had to like increase the limit of connections on our servers to be like pretty high. I think they're somewhere in like 150K, 200K, somewhere in there now. we've had client issues around Java garbage collection. We read a lot of Java, and just the whole object churn of when there are errors and reconnections, and when you have a very large backlog on the event loop queue, can eventually cause your application to be doing mostly garbage collection, which then ruins our latency. So initially, we weren't setting a limit on the number of items that could be in our event loop queue, and that would just cause the queue to blow up, and we'd have a whole bunch of our objects sticking around, and cause of a whole bunch of garbage collection issues. So we had to set the limit on that queue. As part of this answer, it might have been also been affected by all the connection churn and everything that has to be done to create new connections and create new objects and destroy old ones. But in the end, even after we did a whole bunch of Aerospike tuning, the biggest thing that improved our client's performance was non-Aerospike improvements to the client's operating environment. And this was probably our biggest unexpected lesson, that we would have to change things in the client's operating environment. So our application has to do a lot of things. We sort of like pack a lot of things into this application, and getting it to do more things ends up being hard. But there, a lot of people worked on a lot of things to make this better. Notably, like we made better load balancing, so there wasn't like one server getting like tons and tons of requests. We upgraded our Java versions from Java 8 to Java 11, and we actually had to improve the performance of the legacy data store in order to improve the performance of our Aerospike lookups, which was a funny little, like, I don't know, conundrum that we encountered. And now Paul's going to talk to us about another use case.
Oh yeah, I was muted. All right. So all right. So another use case that we'd like to highlight from our migration was the frequency capping use case. This is an ad tech term. So put simply, frequency capping provides controls on the number of ads individual users see. Can someone confirm that you can hear me right now?
Yes, we can hear you.
Cool. All right. Cool. Yeah. So really, like, to give an example, our advertising clients, they want to be able to configure our systems to show more than, say, like 10 ads per month. This is because they know that advertisers, like, they know it's really annoying to get the same ad all the time. Like, they know it's overwhelming to just see the same ad over and over again, and they want to be able to control how often and how many ads you see. So to support this use case, we need to be able to store data about the ads shown for each user and update this as our systems like deliver. So obviously we had to move this migrate this use case out of Keebler and into Aerospike. And so we investigated how Keebler was working for this use case. It was actually using this kind of like general purpose data store inside of Keebler, which gave you a list of key value pairs that were available for each record. Gave you 100 of them. This storage mechanism actually had two use cases primarily, frequency capping being one of them, and then the other one being this kind of short-term activity tracker that we're not going to cover in this. Yeah, so of these key value pairs, the key was actually just a 32-bit integer, and the value was a 64-bit integer. So you didn't really get much in terms of types. You just had some bytes. Yeah, it didn't really have an interface whatsoever. You were just manipulating these two values, really. So we often found code using this that was like shifting around bits. For example, the frequency capping data was using an 8-bit prefix to identify that it was a piece of frequency capping data. And then there's a 24-bit part of the key to uniquely identify that particular piece of data. In another use case of this system, we actually found that the client was putting 3 different values into this 64-bit integer. Yeah, and it didn't really have a proper delete operation either. The way you deleted stuff was you did a write operation, you set the value to the hex value FFFFFFF, and Keebler would delete that internally. And yeah, we actually wrote a whole design doc on how we're going to re-implement this thing using Aerospike. And then we threw it out. We had a long conversation about it, and we thought that it was going to really limit the things we could do in the future. We weren't going to be able to build new products easily on top of it, so we went back to the drawing board. So we went and we understood the use case for customers. We went and really understood kind of what they wanted to possibly do in the future. So we came up with a solution that would better support them. Like we had requests for like longer term caps or more finely gained controls on delivery that we weren't going to be able to support. So we decided to make this better as a part of the migration project. We have clean interface. We're not packing in any values into 32 bits anymore. We're using proper primitives. The data describes itself. We then established an objective correctness metric to actually evaluate our new system. And we evaluated it against what we consider to be base truth. And so once we had that metric available, we started rolling out the new system that was backed by Aerospike. And having this objective correctness metric really helped us during that rollout. It really pointed out if the new system was working well, and it pointed out when we need to fix issues. So that was absolutely critical. So from this migration, there's really 2 key takeaways. One is that you have to deeply understand the use case that you're going to be migrating. If you don't deeply understand it, you might end up re-implementing something that wasn't working well. For example, like we might have gone and re-implemented this whole general key value store that Keebler had when we really didn't need it. And the other key takeaway is that you really need to be able to run your new system in parallel with your old one and evaluate it objectively. Having a metric that tells you that is critical, and also being able to experiment on the systems as you go is critical, and have affirmation about how well they're working. So we haven't just been migrating new use cases either over to Aerospike. We've been doing a lot of new stuff with it too. We've been launching new products. These products, they're in production. They have client adoption, and as far as we can tell, the clients are pretty happy with them. One particular product, we're storing more data about the websites where we're serving ads, and we're actually providing better controls to our clients about those, so they can control their own appearance to the individual customers. And also, we've built more sophisticated systems for handling frequency capping in order to meet client requests. In addition, for using Aerospike, we've actually started using it outside of the RTB use case. We're actually using it in a batch processing scenario as well, and it's improved the quality of data provided to those batch processing pipelines, those pipelines being written in Spark. We've been pretty happy with its performance. The cluster we have set up for that sustains 3 to 4 million lookups per second while that pipeline is running. And we're fielding a good number of additional requests for new data sets, for launching new products as we go. So we've also made some serious cost savings in moving to Aerospike. We've moved to the AWS i3EN instances, which is very dense storage. They're performing very well, and they've saved us a lot of money. We're actually happy to say that with this migration, we are recouping all of the engineering headcount costs associated with performing this migration over the next 2 years. That's the whole Aerospike migration is covered because Aerospike is that much cheaper.
So yeah, that's some pieces of our journey. So we did a lot of work. We slayed the Keebler dragon. We've run riches and feature velocity, and now we're living happily ever after in mostly operational stability when we're not, destroying clusters accidentally. We reached the end of our talk, and hopefully everlasting fame at the Aerospike Summit. Things that lessons learned that we want to reiterate, that it was important to deeply understand our use cases. We had to really dig into what did our customers expect. We had to really dig into what was the system actually providing and how did the systems actually work. We had to understand that the client performance was critical and just as critical as the server performance. And client performance is really tricky in resource-constrained environments. Being able to tune things in production and have metrics to be able to validate our new systems against our old systems was key to having a really smooth migration. Like, we didn't have a lot of issues when we were switching over from the old systems into the new systems because we did a really thorough job in validating the data and having good metrics to validate that data. So there are a couple of Aerospike things we're excited about for the future. We hear that there is improvements for the Java client performance coming in the pipe, and we're interested in trying out the new improvements in XDR potentially. But yeah, maybe we have a little bit of time for some questions and answers.
Well, thank you, Kristi and Paul. And Kristi, first, don't worry about the microphone issue. That happens in these kinds of environments. It happens to every one of us. We all have those stories. Paul, thank you for jumping in and helping out. Look, we did get a number of questions, and I'm going to go ahead and just read them out of the queue. I'll try to read them as is so I don't mess them up. Hold on a second. All right, here we go. So going back to the mesh seed hack as you described it, the question that came in was, did you also evaluate NLB instead of public DNS?
No, we did not evaluate the NLVs instead of the DNS. It's sort of a thing that we started up doing, and we haven't gone back to reevaluate it because it hasn't caused us issues.
Okay, good enough. Next question was, have you considered using persistent memory instead of SSDs? If AWS offered it, is that something that you would look into?
I mean, we'd be curious about it to see, what the cost performance of it would be if they offered it.
Sure. There's, Intel's here, and they presented yesterday, and they have a booth. So if you guys want to check it out, there's plenty of Intel people who could answer that question. But anyway, it's a very big topic amongst our customer base. So just, the question came up if you guys have looked at it. Next question came in was, how do you index your data?
We index our data. So we use Aerospike as basically a key value store, where we have a key for looking up that is an internal identifier, and we just look things up against that key. We don't have any fancy like secondary indices or anything. It's, I don't know, not horribly interesting.
All right. Next question that came in was, Do you run multiple use cases on the same cluster? I think, Paul, you talked about adding use cases. Maybe you can talk to this one, but do you run multiple use cases on the same cluster, or do you run those on separate clusters? And how did you determine that?
Yeah, so the multiple use cases, typically we'll be grouping all of the use cases together when they're accessed using the same key. So if a key is a user ID, we're often really grouping the data that is going to be under that user key, all onto the same record. They'll just be in, separate bins or something. Yeah, like, so for that use case that I discussed, the frequency capping use case, that stuff is keyed by user more or less, and there's subkeys within that.
Okay. This is the last question, and I know we've gone a little bit over, but since we had a little bit of an audio issue, I wanted to allow us to continue to go. And since your slides were so great with the Keebler graphics, and I noticed you slid in an Aerospike rocket, so I have to give you props for that. That was great. So that will get you into Summit infamy, by the way. The last question is this, which is, what other components do you have in your tech stack around Aerospike? What do you use for analytics? And how does it talk to Aerospike as an example? There might be other things you have in the tech stack that you want to talk to, but that's an interesting thing for our customer bases. What other things are in the stack around Aerospike that you've found and that work and that you deploy?
Sure. So for the analytics use case that we talked about in the additional use cases part, that's a Spark job that's running as well. It's obviously a very widely adopted batch processing system.
Kristi, you had something you might add to that.
Yeah, we have mostly Java. We run mostly a Java shop. We've written a little bit of like some Python tooling to monitor some Aerospike. We also have like a we wrote our own file system called QFS, which is open source, and we have that we can like load in data from that is in there into Aerospike, and we have like we actually have like a modeling application that that also like runs in Spark and accesses data from Aerospike. So we're sort of like just at the beginning of trying to integrate more things and figuring out how do we get data in and out and doing analysis in that.
Thank you again, Kristi, and thank you, Paul. Really appreciate you being with us this year and the time you took to put together the wonderful story, particularly around Keebler, very creative. And with that, I'll end today's session and ask people to move along to the next session in your agenda. Thanks, everybody.
Thanks, Bill.
Thanks for coming.